Hello, in this video, the topic is controlling a DC motor with the Arduino Motor Shield 3rd revision. We will learn to connect a DC motor to the shield and to control the speed and direction of the motor. In this tutorial, we will learn about the ways to control a DC motor using the Arduino Motor Shield 3rd revision, a shield compatible with the Arduino Uno. We will take a look at 3 different pins: break, pulse width modulation, and direction, where we will create a simple sketch that uses all 3 of them. We will also take a look at the way that we can power our project using an external power source. The goals of this project are: set up your Motor Shield 3rd revision to control a DC motor, control the break, pulse width modulation, and direction of the motor, connect an external power source to the shield. The hardware and software that are needed are a computer with an Arduino integrated development environment, an Arduino Motor Shield 3rd revision, an Arduino Uno microcontroller, a DC motor, and a power source. There are several ways we can control a DC motor. Perhaps the easiest one is just by applying power to it. Very early inventions using the DC motor simply worked like that: add a power source and the motor will start rotating. Switch the polarity and you switch the direction. But if we want to do a bit more than just making a motor spin full speed in 2 directions, we need a motor control circuit, more specifically the dual full bridge driver L298P integrated circuit, which we can find on the Arduino Motor Shield 3rd revision. With this integrated circuit, we can set the work duty from 0 to 100, enable brakes with a high or low signal, and set the direction with a high or low signal. Each of these features can be controlled using a different set of pins. As we are going to control a DC motor in this tutorial, let's take a look at the pins that are used. We will be using channel A. The pins are D12 for direction, D3 for pulse width modulation for work duty, D9 for brake, and A0 for current sensing. Now, if we were to use just the bare chip, it would involve a bit more complex circuitry. Fortunately, all we have to worry about is connecting the DC motor to one of the channels, connect an external power source, and we are good to go. Let's begin by mounting our Arduino Motor Shield 3rd revision on top of an Arduino Uno microcontroller. Now let's connect the motor to the A channel, following the image shown. The channels are marked next to the screw terminals on the shield. Finally, we can connect the USB cable to the computer. We will now get to the programming part of this tutorial. First, let's take a look at some key commands in the code. We are actually not using a library as the operation is very basic. Int direction pin equals 12 assigns the direction pin. Int PWM pin equals 3 assign pulse width modulation work duty pin. Int break pin equals 9 assign break pin. Digital write direction pin state sets the direction of the pin by using high or low states. Digital write break pin state release or activate brakes using high or low states. Analog write PWM pin 30 write a value between 0 to 100 to set the work duty. Direction state equals not direction state is a boolean that switches every time the loop is run. The sketch or code can be found in the following snippet. Upload the sketch to the board. This is the snippet of the code. Type this code into the Arduino integrated development environment and it will upload this function or process into the Arduino microcontroller. After we have uploaded the code, the program will start running immediately. If everything is working correctly, the motor should start spinning as soon as the program finishes uploading. The expected outcome is that the motor spins in one direction for 2 seconds, with the work duty set to 30, which is quite low, and brakes disengaged. As the code is run in the microcontroller, the digital write direction pin high will cause the motor to rotate left. Then the code will switch to digital write direction pin low. This will cause the motor to rotate right. In both instances, analog write PWM pin 30 will cause the motor to rotate at a low speed. When 2 seconds have passed, the brakes are activated and work duty is set to 0. This means the motor comes to a full stop. If the code is not working, there are some common issues we can troubleshoot. We have not connected the circuit properly. We can double check this by going back to the circuit at the beginning of this tutorial. We have connected the motor to the wrong channel. Remember that the pin definitions in the code need to match the channel you connect it to. The external power source is not working. Double check that your batteries are working and recharge them if needed. In this tutorial, we have learned to control a DC motor using the Arduino Motor Shield 3rd revision. With the brake pulse width modulation and direction, you now have a lot more options when it comes to motor control. Having this type of control allows you to create many different cool projects without having to create complicated programs or advanced circuits.